everyone. Our group name is RecSys Explorers. Our group members have 张康英、韩美兰、廖丽仪 and 李一鸣. Today, our content have 4 parts. Let's go into the dataset exploration. Our dataset consists of 1,591 unique users and 396 courses and 5 different events, such as view courses, detailed description, teacher profile, rundown, and institution. Among these behaviors, the most one is view course, accounting for above half of all user behaviors, with 8,874 occurrence. The second most common behavior is rundown. Furthermore, we identified the top 10 courses in the dataset based on user behaviors. Each of these courses has been viewed more than 80 times. The course with the highest numbers of behavior is identified by the course ID 202. Additionally, we find 3 users, 429, 1014, and 347, who have viewed a total 40 different courses each. Notably, user 1014 has the highest number of user behaviors in the dataset, with a total of 35 occurrences. We then analyze the distribution of behavior counts in the graph above. It becomes evident that most users show behavior ranging from 5 to 20. Based on these insights, our next step involves developing user-based recommendation system and item-based recommendation systems to suggest course to users. Next, Mei Lan will introduce user-based recommendation system part.
Now my part is mainly about the user-based collaborative filtering. The core idea of user-based collaborative filtering is to find users with similar preferences to target users, and recommend items that similar users are interested but the target user have not yet viewed. Similarity is based on items in the other users list. Implicit rating is applied in this approach, with user behavioral similarity used to measure how similar users are to each other. And each behavior is given a different weight, representing a user's interest score for a course. We also need to pay attention that time matters. The user's interests may change over time, and the impact of annual behavior on the user's current interest should gradually decrease. To account for time, we use a decay function, and earlier behavior is multiplied by a decrease factor of less than 1. In this way, the older behavior will have lower weight and have less impact on the user's current interest rating. And then, after subsequent simple normalization processing, we can get the following interest scoring metrics. And we randomly select a user who has not watched all the courses as the target user for the recommended content. The next step is to calculate and sort the correlation coefficients for the target user with other users to find the key users who are the most similar to the target user. After that, we can select the courses in the database that the user has not seen, then calculate the mean scores of these k similar users on those courses, and sort them for high to low to generate the recommended list. And then, we select the top k courses to recommend from the recommendation list as the final choice to recommend to users. The above steps are packaged into a function. When called with appropriate parameters, it can generate a list of key recommended items for a specified user based on the most similar key users. One thing we need to pay attention is the correlation coefficients. While we are calculating the Pearson correlation coefficient, it's found that the wordings are caused frequently. We searched on the internet. It shows that in the calculation of Pearson correlation coefficient, when the variance of the sample is 0 or the number of samples is too small, the degree of freedom is less than or equal to 0, and that's why it causes problems. In order to solve this problem, we use the Spearman correlation coefficient. It's not affected by 0 variance and can produce recommendations exactly the same like Pearson correlation coefficient. Now that's all of my part. Let's welcome my teammate to introduce the next part.
Okay, thank you. And our next part is about the item-based collaborative filtering system we've made. Item-based collaborative filtering means that to use similarity between items as a clue for prediction and recommendation. If most users have data on item A along with data on item B, It means that the similarity between items A and B is high. It means that users with data on either item A or B are likely to be interested on the other item. So we pre-computed the similarity matrix between items to help find items with high similarity. So we made this overlapping matrix to find out how items appear at the same time as each other, and to remove some items or some of the items that are rarely overlapping with others. Then we computed the item-item similarity matrix using the cosine distance in the SciPy library. So when we recommending to a specific user, we need to extract all the items for which this user has no rating data, and use the similarity matrix to predict the user's rating for these items. In this work, we use the UI matrix processed by the previous work. We normalize the ratings basing on the average rating of each user to remove the effect of different rating criteria for different users. For each item, the similarity matrix is used to find the k items that are most similar to it. The average of the user ratings of these items is taken, and then the mean of the top k is taken as a prediction. After the prediction is completed, the item with the highest predicted rating is obtained as a recommendation based on the number of demands. And we found out that changing the number of top k items affects the recommendation results. Also, we set an minimum similarity threshold to check the confidence of the recommendation. Low minimum similarity means that some dissimilar objects were used in the prediction, and this recommendation may not be confident.
The last part is evaluation and optimization. First, we could see the user coverage. We mainly take 4 parameters for reference, and we mainly train 2 of them. Let's move to the results. And then users takes a large value, for example, 100 to 300 or so. Then items takes a smaller value in 10 to 30 or so. It's a more appropriate value. And for catalog coverage, in determining the threshold, we have selected more appropriate overlapping ratings, which means that overlapping users' ratings have been determined to be in a very effective range, meaning that a lot of courses that rarely appear at the same time as other courses are filtered out, which can be seen later in the tuning. But it also means that the catalog coverage of the recommended course is low. The average time spent on tuning by traversing user IDs is huge, so the performance of catalog coverage can be evaluated later in the choice of key values. And the tuning for item, we could say we only take 6 parameters for reference, and we only take 3 of them to change. Let's move to the results. A key value is too small will lead to data credibility is not high. It is easy to be affected by the individual anonymizing the data. Key value is too large will be mixed with a lot of data with low similarity. When we set the minimum similarity threshold, it will lead to a small number of recommended courses. So key value between 5 to 10 is an appropriate value. And we also met some challenges. The first one is when we calculate the user coverage, it was always 0 or 1. That means the recommendation was valid. Later, we found that it is because when defining a recommendation function, we did not remove the value of none from the final recommendation results, so that when we ask for the output results, there would be a corresponding number of recommendations, and at this time, the user coverage will always be 1, which is actually inaccurate recommendation results. And second, in the recommendation, there will be some data displayed as 0 for users. In fact, the decimal point is very close to the back is not displayed, but in order to ensure the integrity of the recommendation, we still retain this part of data. And the third one is, at the beginning, we did not add the parameter of minimum similarity. The recommendation performance seems to be quite good. But since a prediction score can't actually be used as the basis for the evaluation of similarity, the recommendation results are not really evaluated. So we decided to add the minimum similarity parameters, so that similarities below a certain threshold will be excluded from the recommendation results. The similarity can also be measured by setting the threshold size, at which point the recommendation is more hierarchical and personalized. That's all for our presentation. Thank you.